This is part 3 of section 4.2. We want to talk about finding some exact trigonometric functions. And we're only going to be able to find exact function values for some special values of t. And for the others, we're going to have to use a calculator and settle for an approximation. But we're going to start building up the ones that we can figure out exactly. We're going to start off with the points that we would use if we were going to just graph the unit circle by hand. Remember that what you normally do is you plot the center point, and here that's the origin, and then you would normally go up, down, left, right, the amount of the radius. So since I'm at the center, if my center is the origin, if I go up, down, left, right, 1 unit away, I get these 4 points, okay? And now remember that the circumference of the unit circle is exactly 2 pi, okay? So what we have is a situation sort of like this. We have these 4 points. All right, and remember that our trig functions are, right now we're talking about arc length. So if this is my starting point on the t-axis, 1, 0, then remember that's where we started, and then its t value right here is 0 because that's how we defined where we placed our t-axis. Therefore, p of 0, when t is 0, when our arc length of 0, that gives me the point 1, 0. Okay? Now, from here to here, that is 1/4 of the way all the way around. Okay? And the whole distance is 2 pi. If we divide that by 4, we get pi over 2. And we know that that point is 0, 1. Okay? So that means if we're asked to find the trig functions of an arc length of pi over 2, this is our associated x and y value. If we go half of the way around, we're all the way over to here. So this arc length is half of the whole 2 pi, which is, so it's just simply pi. And it is associated with the point -1, 0, again, our x and our y values. Okay? And then here, this is 3/4 of the way around. So if I multiply 2 pi by 3/4, I get 3 pi over 2. And that's associated with these x and y values. Okay? So we're going to talk about these 4 points. In particular, these are our quadrantal angles. And we want to note that coterminal points have the same trig values. So this is 0, p of 0. All the way around would be 2 pi. So p of 2 pi is going to have the same associated point, so it has the same associated trig values. Okay? So let's talk about finding the values, if any of them, of the six trigonometric functions if t is 3 pi. So first of all, we need to figure out what point is associated with 3 pi. From here to here is 1 pi, 2 pi, 3 pi. So 3 pi is coterminal with pi. Okay? So that tells me that p of 3 pi is the point -1, 0. So now we use this point and our definitions of our trig value, our trig functions, to get our answer. So sine of 3 pi, cosine of 3 pi, and tangent of 3 pi. Sine is our y value, so it is 0. Cosine is our x value, so it is -1. And tangent is y over x, is sine over cosine. 0 over -1 is 0. Okay. Now let's talk about our reciprocal functions. The reciprocal function of sine would be cosecant. Cosecant of 3 pi is the reciprocal of 0? Well, that would be 1 over 0, and we're not allowed to have 0 in the denominator. So this is undefined. Okay, this is how your book says it. Depending on if you learn this in high school, you may have been told to say this does not exist, or DNE. Just in case you've heard that notation before, that vocabulary before, it means the same thing. All right, let's talk about the reciprocal function of cosine. That one is secant. Secant of 3 pi is the reciprocal of -1, which is still -1. Now let's do cotangent of 3 pi, which again is the reciprocal of 0, which is still undefined, or does not exist, depending on how you may have learned it in the past. Okay, so we've talked about arc length, but we can also talk about the angle, the trig functions of an angle, and these are very closely related. This is what I meant when I said you're going to feel like I'm defining things twice. Okay? Remember the formula from the last section where arc length is equal to the radius times the angle, where the angle is in radians. Okay? Well, if we're talking about the unit circle in particular, then our R value is 1. So our arc length is the angle. And when we defined our trig functions, we said that t was the arc length. So if our arc length is s and s is theta, that means that is the Greek letter theta, that means that sine of that angle is the same as sine of that arc length. So as long as we're talking about a unit circle, we can define these exactly the same way. Okay? So if I want to find the trig function value of sine of -pi over 2 radians, think back here. Negative angles go clockwise. If I am starting here and I go -pi over 2, that puts me down to here. So this will be the terminal point I am interested in, which is 0, -1. Okay, so 0, -1 is my corresponding xy value. Sine is your y value, so this equals -1, exactly. Okay, now if we're talking about cosecant of -720 degrees. Now the first thing we want to do is we want to figure out what point this is coterminal with. Okay, so if I start here and I travel around this way, that would be -360. And then if I travel around again, that gives me -720. So -720 degrees, this is coterminal with, and therefore the same as, cosecant of 0 degrees. Okay, and 0 degrees is the same thing as 0 in radians, and it is associated with the point 1, 0. Okay, now this is a reciprocal function, and cosecant is the reciprocal of sine, right? Because every grouping needs a cosecant. Sine is your y value, so that means cosecant would have to equal 1 over 0, which does not exist. So this is also undefined.